Good morning, good afternoon, and good evening, everyone. And welcome to day one of our 12 days Geospatial Python Bootcamp. Today, we will introduce ourselves to Fiona and Shapely. And with these two packages or Python libraries, we will look at how we can work with shapefiles in Python. So let us get started. So let us take a look at today's outline. We will introduce ourselves to vectors in GIS and vector files also in Python and GIS. We will also look at how we can represent points, lines, and polygons in Python, and then how we can use Fiona and Shapely to handle shapefiles. Okay, so what are vectors in GIS? The vectors are geometric objects used in GIS, which is Geographic Information Systems, to represent real-world features. And in the basic forms, we have them as points, lines, and polygons, each of them representing a different type of geographic entity. And vectors are scalable, lightweight, and very precise for representing even very discrete objects. Buildings may or may not be discrete, but even some discrete points, like a single point like that of a pole, can be represented by a vector to such a substantial accuracy. And even very thin and sensitive stuff like the administrative boundary of countries, you can use vectors to also represent that. And so what are vectors in Python? In Python, vector data can be manipulated with libraries like Fiona and Shapely, which we'll take a look at today. And this will allow us to, of course, create and read. When we say read in programming, we just mean that you will open a file in QGIS. In a programming term, we will say read instead of open. And then write, which is now creating a file. Okay, the read write, the create shouldn't have been there. It's an error. So read write. I think I was trying not to be technical and I forgot and I was technical at the same time. So read write, that means create and open in the less technical form, and then manipulate vector geometries also. So perform certain operations on vector geometries. And so some of the common vector files in GIS. We have the XRE shapefile. XRE shapefile, that is the most widely used format for vector data in GIS. If you are a GIS person, then you should know about XRE shapefile. And there's also one called GeoJSON. JSON is a short for JavaScript objects and notation. Let's see that one. Let's look at that one quickly on the internet. So JSON, it is a format that data is represented in. Makes it quite readable. If you are coming from JavaScript, you should know what JSON is. So it says JavaScript object notation. So if we take a look at their website, okay, so at the left side here, no, sorry, at the right side here, I think it's, I'm looking for a representation, something like a JSON file, and I'm not really seeing one here. Okay. I'll show you. If you are familiar with Python dictionaries, then you should know what JSONs are. We use the brackets, this braces to represent them left and right. So, and then each name is followed by the value that is associated with it. We will get to know how it looks like very soon when we are creating a shapefile. And then, okay, I think this has skipped forward a bit. And there's also the KML, which is used by Google Earth to also represent its vector points, vector data set. And also some of the examples of vector data types, I told you that at the core, we can break them into three, being points, lines, and polygons. And every vector file that you'll be using is either composed of one or more of these. So this is vectors in their basic forms. And an example of points, you can think of a tree, bar stop. If you want to just pick a point on the bar stop, you can use a vector, a point to represent that. And for lines, you can think of stuff like road, rivers, and anything that can be represented in the form of a network. And for the polygons also, they are closed shapes formed by lines. So this is how it looks like. There is a point, which is a single pair of XY coordinates. And then there is lines, which builds on points. So a line is just a series of points connected by straight segments. Even if it's a curve, no matter how smooth the curve is, if you zoom in well, you see that it's just so many dots being connected by small segments. So a line is a series of points connected by straight line segments. And a polygon also builds on lines. So if a group of lines close on each other, so it starts and ends at the same point, that means the start point coordinates and the end point coordinates of that particular line type is the same, then we can say that that is a polygon. We can take a look at maybe boundaries. We can look at lakes, and buildings can even be represented as polygons also, if we are taking the whole shape of the building into consideration. Okay. So some of the properties of vector geometries. For points, points have no length or area. As I said, it's just a single pair of coordinates. So it has no area. It's just a coordinate that is just there, and then that is all. But lines have a measurable length. You can measure the length of a line. And usually they have directions also. So we can say that the line that moves from, say, point A to point B. So if you are describing a particular road, a particular street, you can say that it starts from, say, the traffic light up onto the mall. So you are using the traffic light as the start point and the mall as the end point. So you can say that that is in itself is a form of direction that tells the user that, okay, if I want to get to this place, then I have to be from here to here. And then there is also polygons, which encloses an area. So polygons have the area property, and they also have the property of the perimeter. That is, you can calculate the length of the boundary. The perimeter is the length of the boundary that encloses that particular area. Okay, so having gone through all of this, I think it's high time we look at how now we can represent these geometries and everything else in Python code. If you went through the installation video successfully, then you should have all of them installed on your system. And so what I would do here is I like to keep my things very organized at one place. So what I recommend that we all do is that this is my Explorer. I'm coming. This is my Explorer. I don't think it's really that big for you to see, but okay, I can zoom in here. This is my Explorer. And so what I will do is that I will create a folder here. So I right click, create a folder. No matter the operating system you are on, you can just create a folder. This is Linux, which I will call maybe 12 days Geospatial, or maybe GeoPython, so that I'll keep the name short, GeoPython training, something like that. And then that folder will be there. And everything that I will do in all of the 12 days will be inside this folder so that it will be well organized. It's just a matter of preference. You can choose not to do so. And so here I will also create a new folder for day 1, like this. And then what I want to do now is this file, this folder here, I want us to register it first in VS Code and also in QGIS. So what you can do is to open your QGIS like this, and then you at the left side there you see home. I really wish I can zoom into the text so that you see it, but unfortunately I can't do that now. Maybe I'll have to go into settings and something like that. Maybe options. Let me see if I can get the option to enlarge the screen for you to see where I'm clicking. Maybe not now. I'll try and do it off stream. It might take some time. I don't know how to do it. So, but you can see that there's the home folder there. And then my folder, which I created, which is 12 days GeoPython training, is also there. I'll right click on it. And as part of the options that will pop up, I will see add as a favorite. So when I click on the add as a favorite, it will add it to my favorites up here so that anytime I need it, I don't have to go to the hassle of getting the going down the directory tree. Okay, so you can see the parent folder here and the day 1 inside of the parent folder. That is great. So we have registered it in QGIS. So what we have to do is to register it also in Visual Studio Code. So I'll open up a window of my Visual Studio Code. That one too is here, a fresh window of Visual Studio Code. And then what I can do after closing this welcome is that I will drag this folder. I will have to find a way of dragging it into the VS Code editor. So this is my folder. This is my VS Code. I'll hold the folder like this and then drag it inside. When I drag it inside, VS Code will automatically pick up the folder, the workspace. So usually, if it is the first time you are opening a particular folder, it tries to protect you from threats and some viruses that, in case you download the folder or it's a file or folder you got from the internet, it tries to protect you by asking you whether you trust the authors. And in my case, I do trust because I created the folder. So I trust before it opens up for me to use it. Okay. So let me make it full screen here. Okay, so this is VS Code. And let's take a quick tour of the interface. So when you open it up like this and drag your folder inside, the left side here, we see a couple of icons. Maybe you have the same as mine. Maybe I have more than you, or you also maybe have more than I. It doesn't really matter. But what I want you to take notice of is this Explorer side. When I click on any icon, it either expands or collapses. The first one is the Explorer. That is where we can see the files and folders at the workspace where we are working. So the workspace is just the folder that we dragged and dropped inside the Visual Studio Code editor. And so now you can see that I have only one folder in there called day one. Okay. And then the next one on the list over there is search, which is a universal search. As time goes on, we will know how to use it, but just know that we use it to search for maybe lines or keywords inside of all the files in the workspace we are working in. Source control is for source control stuff like Git. And so we're not doing Git now, so we will not bother ourselves with that. And this run and debug is a place where we can also debug our code. The debugging is just a fancy programming term for catching errors. So anytime you hear a programmer or developer saying I'm debugging, the person is catching errors. And then this space, you are familiar with it because of yesterday. This is the extensions tab where we install all the extensions that we need. And I do have Docker here. I don't know whether you have it, but this is way beyond the scope of this training. It's I don't even want to explain it. Just let's leave it like that. It's something that software engineers use to build their software, and it's way beyond our scope now. This one's here, settings. If you want to do certain things, you can come here and your user account also and all that. And then this big black space, which is currently blank with just the VS Code icon here, is the place where we will be typing our code. And then we have our status bar down here also like that. So today we will look at how to, of course, work with shapefiles in VS Code. So we will create our first file and write our first lines of code. So if you want to create a file in Visual Studio Code, if you want to create a folder also, you see when you select any, this is the parent folder, the 12 days GeoPython training. And then there's the day one folder also here. If you want to create a file directly inside the parent folder, what you can do is that you select it, make sure it has this blue highlight like mine has here. And then, you know, the four icons, the first one is new file. When you click on it like this, you have the option, text box pops up with a cursor blinking. And by that, you know that it's asking you for something to type. So if you can just follow me and type main.py, which is a Python file. The extension .py means it's a Python file. Okay, so now this file is not located inside this folder. It's located inside the parent folder itself. But if I want to create a file inside day one, I will select day one, make sure it is blue like this, and then I'll click on the file. Now you see that the file that I'm about to create is nested inside the day one folder, which I'll also call main.ipynb, which is quite a long one, but it means interactive Python notebook. So that is what we'll be using a lot in this tutorial. There are times where we'll use the regular .py files, times where we'll use the interactive Python notebooks. But if you are wondering the difference between these two, the interactive Python notebook, as the name goes, allows us to write our code or do our stuff interactively. So we write the code, we see the results in the file. If it is a plot, if it is a chart, if it is a table, whatever we are printing or displaying, we will see it in the file. We don't have to come and see it at the terminal. But the Python file in itself, we will have to type everything. And this one is actually technically called a script. So after we type everything, we run the script and then we see our results. But this one we will run and get our results in line. So it was just for demonstration, but I will not delete it. I'll only close it here with this X. I hover over it and then it closes. In the same way, if I want to create a folder, I use the second icon. So now I select the one, I click on folder, and here I'll create a data folder, We will use this data folder very soon in the tutorial. Just make sure that you have this structure like I do. Maybe this Python file, I should delete it. So I right click and then choose delete, or you can press delete also on your keyboard and I'll move it to my trash. This one is to refresh the Explorer. In the case where maybe you have copied and pasted some data in your folder inside your Finder. Now you do it here instead of coming to do it in VS Code, like you have done it here instead of doing it in VS Code. But you came to VS Code and it was not showing. You just click on the refresh and then it will refresh your workspace and the folder for you. And then the last one, which is collapse folders. If I click on it, it will collapse everything that I've opened. So if I've opened any nested file and folder structure here, once I click on this, it will collapse all of them for me in a neat and nice format. Okay, so now that this our file is created, we don't need this Explorer. So I'll click it and collapse it so that we get a lot of space here to do what we want to do. Now let us explore this interface of the interactive Python notebook. You can see here that it says code and Markdown. So here, if I click, if I want to type some code, we will type our code in something we call cells, which is just, you will see what cells are. I don't have to explain it that much. And then Markdown is a place where we are not typing code, but we want to put in some text as a form of description so that when anybody sees our file, they know that, oh, this is what I was doing. Maybe I was creating a shapefile. Those texts, they are not code. They will not be run. They just give description to whoever is viewing your file. And then the next on that, on the list is run all. That means if we have typed code in multiple cells and we want to run it from top to bottom, we can click on this button and it will run all of it for us. And the clear all outputs is now grayed out because we don't have any, we have not run anything. We don't have any outputs. So we can't clear output. And then we have outline also. The outline, it will pop up down here. So if we have any variables or any variables or objects in memory, we should see them there. And if I go to more options, I can export this shapefile, this notebook and everything. And here we see the code and Markdown file buttons again. We will use one of them very soon. And this kernel here, think of it in a less technical form. The kernel, think of it like is the engine or let's say the engine that will run our code. So we type the code and we give it to the kernel and the kernel runs it in the less technical form. Okay, so let us look at how we can now represent those vector geometries in Python. So I'll first add a Markdown here. So I click on it and this is a Markdown. And you don't have to memorize this syntax, but if I precede it with three, I think this, is it called pound or hash symbol, however you call it in your language or your area, and I can say maybe something like representing points. When I finish, I can press Control and enter, or if we're on a Mac, it's Command and Enter, and it will render out to be something like this for me. So if you want it to be smaller in font, this is Markdown syntax or Markdown way of writing. That is not why we are here. So just know that if you want to give some description, and if you want it in the form of a heading, a nice one, just precede it with some number of hash symbols and your text, and after that, hit Control or Command Enter. And then after this, I want to add code. So when I hover over that particular line, we can see that this blue side is a cell. This thing that I typed inside, this blue outline is a cell. That is what we call a cell. So Control or Command Enter. When I hover over a cell, I can add another Markdown like this, or I can add a code cell. So this now becomes a new cell, and then I can add code either above or beneath it. So let me add a code above this one so that it will be beneath the representing points. But this particular markdown, I don't need it now. So if you don't need it, see that when you hover over a cell, there are also some other actions that we can perform. So you can see a lot of them here, But the one that I wanted to show you is the fact that you can delete it if you don't need it. Okay, so this is a code cell. And because we have not selected a kernel for our notebook, it is saying that it is plain text. So click on select kernel. And then here we go to Python environment. And if you went through the installation, you should see your environment that you created here. I had a base, there was GeoPython that I created, and this Geospatial that I also use for my Geospatial stuff. So this GeoPython and Geospatial, they contain the same packages. So, but because we are all using GeoPython, let me also select GeoPython. So when I select it now, you see that now the language here has changed from plain text to Python. That means that just with this now recognizing that I'm about to type or whatever I will type in there is Python code. Okay, someone is saying that is Shift Enter on Windows. I think that is also, yes, that one will also work, but Control Enter on Windows also work for me when I'm using Windows. Okay, so how do we represent a point in Python? I told you that the point is just a single pair of coordinates. And one also important thing I have to show you here, you see that my main.ipynb has this. When I hover over it, I see the X. But when I leave the X, I see some round dots there. If the file is not saved, you see that round dot there. So if I come here, File, and choose Save, or use the shortcut, which is Control or Command S, that thing will be gone. But if I make changes to this file by maybe typing something, and I've not saved it, you see that it is still there. It is a good practice to be saving your code as you go along. And if you are that type who will forget to save it, sometimes if you forget to save it, you see that you've typed the code, you run it, but you don't get the results. Because what Python does is it takes the current version of the file that has been saved and runs it. So there's this cool option in Visual Studio Code. When you go to the file at the top, you scroll down, you should see one of the options that says Autosave. Currently, mine is off, so you not see the check mark here. But if you click on it now, and I go again, I see that there's a check mark behind or beside Autosave. This one, when I make any change, I will not have to hit Command S or Control S. It will save it for me automatically. So I like this style, and so that is what I will be using. Okay, so let's just like the tradition of all programming languages, just type hello world and see how the output will be. So this is our cell. We have our Python code in there, which doesn't do anything other than printing hello world. And I don't think you are new to Python because you should understand this syntax. If you are completely new, just know that the print is the standard output manager for Python. If we want to display anything at our terminal, or if we want to see anything printed or shown to the user, we use print. Okay, so apart from the shortcut, which is Command or Control Enter or Shift Enter, also on Windows, maybe it will work also for other platforms. At the left side, you see this play button here. So you can click on that one too, and it will run the cell for you. So this is the output here that has been run for us. Okay. And so if I change it from hello world to hello Tom, I can either click here to run it like I did at first, or Control or Command Enter. I'll be using the Control Command Enter most of the times because it's handier. I don't have to be moving my mouse all the way to the left here. Okay, so we are representing points. We are not printing hello world. So how we represent points is using Shapely. So let me even bring up the Shapely documentation. Okay, the browser was taking a while to come, so I can say Shapely docs so that we make some references there. Okay, so the Shapely user manual, this one. While it opens, let's us go back to VS Code and then get things started. So here, there are a few ways to go about it, and we have to first get the particular object from Shapely. So we can say from, and then because we have Shapely installed, Shapely dot geometry, we want to import. We can import points here because we are representing points. This means that inside Shapely, there is a particular object or manager called geometry, which also has the points feature. Remember, I told you that in the very basic form, vectors are points, lines, and polygons. Okay, so once we import this one like this, we can define a point. If we give a variable like point equal to, then now we can create a point object using the points. We can create a point object using the point class from Shapely like this. And all that we need, if we put our cursor on it, it will tell us that a point is a geometry type that represents a single coordinate with x and y and possibly z values. And so it's a zero-dimensional feature. As I said, it doesn't have length or area. So we have to pass in the xy that this thing is asking for. If we scroll down a bit, I think we should see examples here. We can pass it in like this, or it can come in also as a Python list. But I think I'll go with a simpler version. So if I pass it in like this 1.0, that is my x, and my 2.0 as my y. This here is a point object. So if I choose to print, I can print the points. When I run this code, it should tell me that it's a Shapely point object. It doesn't really say so much, but that is it. It's correct because it's a point. But if you want to know exactly what it is, we can say print the type of. Okay, I mistakenly split the cell. So let me delete this one. Okay, so what I wanted to do was to print the type of points. That should give us something. So we know that it's a class that belongs to the Shapely point object. Okay, so this is how we represent points in Python using the Shapely point object. Okay. So we can change this heading to representing lines. And then don't forget to Control Enter. And here we can, in place of the line, also import. This one is not just line like this, it's called line string. Line string. That is how they named it. And then remember, I told you that a line is just a series of points that are connected. So here we will define our points in a Python list. So points, that should be equal to your Python list. And then maybe we can say that the first coordinate is 0, 0. The second one is also maybe 1, 1. No, 1. That means 1x, 1y. And then the third one is also 2, 2. And that should do it for now. And so what we can do is that if we are creating a line, we will call, instead of points here, we will call line string, the one we imported at the top there, and then we can pass in our points. So when we also decide to print line, that one should also show us what it is. And you see that it says it's a line string with this set of points. So this 2, 2 is the points, 1, 1. Those ones are the points. And then if you want to represent polygons, it's also quite easy. That one, let me change it. This is representing polygons. And here, instead of line string, we import a polygon. Okay. You know, 2 points form a line. But if you have more than 2 points, you can form a polygon. Because a triangle in itself is also a polygon. Because it starts and closes on itself and it can define an area. So in GIS, we can call it a polygon. But if I only have 2, so let me just get rid of this and then pass it in as a polygon. Let me change the name to poly. And if I choose to print poly, I'm expecting to get an error. Maybe I will not, maybe I will. Let me see. And we have our first error of the training. That is value error. Usually when you get an error when you are coding, don't be bothered about the first line. Scroll down to the last one. That is where the most meaningful test is. So it says we have a value error. That means there's an error with some of the values that you have passed in. A linear ring requires at least 4 coordinates. A linear ring requires at least 4 coordinates. So we cannot put 2 coordinates inside here like that. Let's just trick it and pass in 3, then run it and see. Even though the error was saying that it requires 4, you see that it actually took it for the third one because this one in itself can also enclose an area. Okay. So before we proceed, I think we can now take a look at the Shapely docs. Okay. So this is where we were, and I think we are at the geometry side where we have explored the geometric objects. You know, it is not everything on the documentation that I can teach here. Other than that, it will be so lengthy. So we've explored the point, the line string, and the polygon. So you see each of them here in their description. We can have multi-points, which is a collection of 1 or more points. Think of it like you want to map all the maybe ATMs in your community or in your area. There will be multi-points, more than 1 point. You have multi-line string. If you want to map all the road network in your area, it's more than 1 line string. Multi-polygon if you want to map all the buildings in your area. And there's also one called geometry collection, which is a collection of 1 or more geometries. So maybe a polygon that has a line there. I think when we click on it, we should see an example there. I think they do well enough to show images, but I think they didn't show some here. Okay, maybe we'll get to that place. Okay. So that is it for the geometry side. We will explore some of the geometry properties also. But before then, we have to also learn how to create our own shapefiles with Shapely. Okay, with Fiona, sorry. So the creating of the shapefile, that we'll do with Fiona. So what I'll do is I'll make sure that this line is selected, and then I'll create. Okay, let me expand it. Let me create a code. Okay, let me expand this first and create a Markdown. So here I will name it. I want it a very big heading. So writing, that is the technical name, writing a shapefile with Fiona. Okay. Let me take a peek at the comments. Okay. I'll try and add all these new stuff in new cells or as we go along. Okay, so you can see in our data, this is the time that the data folder will be useful. You can see that there's nothing inside of it. If I open it, if I bring up my Explorer, this is the one, this is data. You see that this folder is empty. So we will write our first shapefile inside this folder, and then we will open it in QGIS. Okay. So the first one will be a simple point shapefile. And we will need Fiona. So we have to import Fiona. And we will also need, so we are creating a point shapefile. So what we can say is from Shapely.geometry. We want to import point because we are creating a point. And then we also want to import mapping. I will explain what mapping is and what it does. So I will run this cell. And what is this saying? Okay, so I have an error that I think arose from my installation of Fiona. Okay. Yes, this is one of the things I was talking about. Some of these stuff are very difficult to set up. So what I'll do is that I think I have it working on my Geospatial. So I'll clear all outputs like this. And then I will restart the kernel. That means I want to restart the engine to clear everything that is in the memory, like that. And I'll even change my interpreter. So I'll select another kernel. Let me choose the Geospatial for the purpose of this demonstration. I think that one has the Fiona working. It should. So if I run this now, yes, it's worked. So I'll try and fix that particular error with my GeoPython. And so the next line of code, what we want to do is we define what we call a schema. The schema is more like the structure of the shapefile. So in the schema, we will say that we will tell Python that the geometry of the shapefile we are creating is a point. And then if there are any columns or attributes we want to add, we will tell Python at that place also. So we go and say that schema, you can name it anything that you want. It's just I am following conversion. This is the red you see here is the job of the error lens telling me inline that I have done something which is not right. So if I complete the sentence, it will go away. You shouldn't fear about that. And so we define that in a Python dictionary. So this is more like a JSON, but in Python, we call it a dictionary. The most important one here is the geometry. Make sure that this spelling is exact. You don't have to use your own words. And then this one also, you make sure that it's a point. It matches what you, so if you are creating a line string, it matches exactly what you imported up here. Then I can add a comma. And then there's another part we call properties. It is inside these properties. Make sure you wrap them in quotes, either single or double. It doesn't matter. And inside these properties is also another dictionary. It shouldn't be confusing at all. This is the general schema telling Python that we want to create a point shapefile. And the properties, think of the properties as the attributes of the shapefile. So here we will only add one field so that I'll show you what it actually means. So I will add ID. Inside the properties, don't forget to open your curly brackets again. And then this ID, I'll define the data type as an integer. I will repeat this same process in QGIS so that you get to appreciate it. And so I want to only put an ID here. So that is all. My schema is complete. And then how I create the shapefile is this. I can define the path to the shapefile, which in my case, because I'm working in the same directory, I can say /. In programming, dot refers to the current folder where I am. So the current folder where this is inside the day one folder. So if I say dot, it means that I'm referring to day one. And then here I want to put it inside the data folder, which is inside day one. And the name of the file itself, I want to call it maybe point.shp. Don't forget the extension. It is very, very necessary. In programming, you have to be very intentional about everything you do. In ArcGIS or QGIS, when you forget it, it will add the extension for you automatically. Python will not give you that flexibility. So once that part is also defined, what I can do is say with Fiona.open, and then in here, I pass a couple of things. This open, what it does is that it opens a collection for read, append, or write. So if it doesn't exist, it will create it. And so this shapefile doesn't exist, but it will create it for us. So we first pass in the path, which is what we have up there. And then we define the mode. The mode here should be W. If you hover over this open, it will give you some of the description there. It says in write mode, which is W, a driver such as every shapefile is required. So let me copy this. Or let me not even copy it. I'm looking for the place where it says something about the mode. Okay, so you see that one of the mode is W, which is the mode for writing, and that is the technical term for creating. So we want to write, and then we have to specify the driver here that is, oh, this thing should go off. Every shapefile. And then the last but not least, other things we can specify, but these are the most important ones. We pass that the schema equal to our schema, if I can spell schema correctly. So this is it. It's quite long, given that we just started, but we are just opening or creating this file. And then in write mode, that means we're able to write to the shapefile. We want to use the Esri shapefile driver so that we can create an Esri shapefile. And the schema, the structure of our shapefile is defined by this particular schema here. And usually you want to open it as maybe SHP. You can open it as Tom. You can open it as anything. But by convention, you just have to follow some of. You make your code readable. So you open it as SHP and terminate that statement with a colon. Maybe I should zoom out a bit so that you see the full code. So as SHP, and then in here, what we do to create the shapefile is say SHP.write. Remember, we are in write mode. So what do we want to write? We want to write first. So inside this round bracket, again, bring this curly bracket. I know it's a lot of convention and rules you have to follow, but once you do this thing 2 or 3 times, it shouldn't be so difficult to follow. And in here, we specify that our geometry, make sure you get the spelling right and exact, is mapping. You remember we imported mapping at the top there. What do we want to map? We want to map a point object. And what is the point object? The point object is, say, maybe has coordinates 1, 1. And then after that, we can bring a comma and specify the properties. And inside the properties, remember that we have to open up a set of curly brackets again. And these properties, I think we have already defined it up there. Maybe we should just say properties equal to, because that means we are typing redundant code. You can say it's equal to schema dot properties. Okay. So that means that instead of typing all these parts again, we are telling Python that the attributes of the shapefile should be the properties of schema. Okay. Now, what is this mapping doing here? Remember when we printed the type of points, it gave us some points in a form that is not really readable to us, but Fiona cannot use that. So what this mapping does is that it converts the Shapely object into a GeoJSON-like mapping, which is compatible with Fiona. So it just converts the Shapely point object, if I'm being less technical, to a point which Fiona can understand. And so that is why we import the mapping over here. So that is all we need to do to create a shapefile in Python. So to test it up, we can click on run here. And if we don't see any error, or I didn't even finish saying if you don't see error and we have an error, it happens to be that I cannot just use schema.properties. So let me access it like proper Python dictionary. So here I can say properties like that. And then I'll run this particular cell again. Now it's finished. You see that when I put up my cursor on it, it says Sussex. And so when I go into data, I have these files in here, which defines a shapefile. So we have created our shapefile in Python. And if we go to QGIS, where's our QGIS? Inside that folder, data, you should see a point.shp. If I drag it in, I see this dot here. Of course, I cannot zoom in and make it so big, but I think you can see it. If I go to my attributes table, right-clicking and go to attribute table, I see this. It has a column, one attribute called ID, which is 0. And that one is populated by default, by the way. So let me remove this and let's modify the shapefile again. I removed it before modification because of the file integrity error. So let's say I want to add more fields to this particular shapefile. Then what I'll do is I will just add it up. How many fields, whatever thing you want to add, any attributes you want to add, you can put it there. So let's just say a description field, which in the schema, you specify the type. So it should be a string, an str. And then in here, I cannot use now I cannot use this schema.properties because I will have to specify the particular description that I want to use. So in here, what I'll do rather is to now say, bring up my curly brackets again, and I'll say that the ID, that should be 1, and then my description, hope I got it correct, description, that should be, let me just enter some dummy text there, say some description. And then that one, if I run this again, I should see my green success. If I come back to QGIS, and then load this point shapefile again, visit the attribute table. I will see that I will now have one more field added, and the description was not typed in full. It came to description. I think that is because the shapefile column names are limited to about 10 words or so. Yeah, it's limited to about 10 words. So if you are giving headings to your columns, make sure that you limit it to 10 words. Now, this is a single point shapefile. What if you want to write multiple points in there? Well, then we can easily duplicate this line here. If we want to get 2 points, can copy, and then the next one and do shp.write again. Maybe I'll change this coordinate to 2, 2. And then let me come back to QGIS, make sure that I've removed it from here. Other than that, when I run it, okay, let me show you why I remove it before I run my code. So I run the code now. Okay, now it's worked. This languages, they can throw surprises, but usually it will throw file integrity error if something like that happens. So now you can see that I have 2 points here. So I've been able to create multiple points. If I go to attribute table, I have 2 points, each of them having an ID of 1 because I forgot to change that for the second one. Okay. So let's just say that I want to, you have a series of points. So I'll copy one from my notes and I'll paste it here. After the schema, I'll paste my points. These are the points that I want to use. It has 3 stuff. So the first one is the X, the second one, the Y, and then the third one, I plan to use that for the ID. So for this first set of coordinates, this one is the X, Y, and then the ID. So if you have a set of coordinates like this, how you can simplify this is to use the Python for loop. So I'll cut this one off, and then I can iterate and say for X, comma, Y, comma, should I say maybe point ID in point. Then I can paste this one in, and here I can replace this one by X, this one by Y, and then this one by point, say point ID. And if I want to make the description dynamic, I can put an F string here, say some description for, and I can plug in the point ID. Okay, so I know I've done a lot in here, but what I'm doing here is that I have a series of points, there are 4 of them, and I want to create a shapefile for the 4 points. So I created over them, and then now I can click on run. It is successful. So let me come back to QGIS and then remove it before I bring it back again. Now I'll have 4 points all in line here. And when I inspect the attribute table, it says some description for 1, 2, and 3, just like we're expecting it to be. So that is how you can create a shapefile in Python using Fiona and Shapely. Let us quickly take a look at how to. So if you want to create a line string, a line shapefile, that one too, let's go over that one quickly. And sorry, my VS Code is off. Let's go over that line shapefile quickly. Then we apply the same knowledge for the polygon also. So I'll do that one quickly. I don't really have to be importing Fiona again because it's already imported in the notebook somewhere. But for the purpose of keeping everything in one cell, let me import it. So import Fiona, and then from Shapely.geometry, we want to import line string. And then we also want to import the mapping. We need it almost all the time. And then here I'll just create a simple schema. Set that one to be equal to Geometry, don't forget this one. This is the most important column you have to add. And then this time our geometry will be a line string. And then I can add in some properties. These properties, I will not really complicate stuff. I will only add an ID, which should be an integer. Just that one. I will not complicate stuff. And so here I can say that, let me bring the points up again. So I use the points to create the line. So I can paste the points here. And then here I can say that with Fiona dot open, and remember that we want to set another path here also. So let me copy and paste so that I'll be a bit faster. So the points and the path, but this one will be line.shp. We are creating a line. So I will pass in my path here, and then the mode is right, and then the driver is our Esri shapefile. And then the schema is equal to schema. This pop-up. So we open it as maybe DST, or let me make it SRC. And then we can now say that our line that we want to write, sorry, not the line string. Our line that we want to write equal to line string, and then we pass in these points that we have at the top there. And then after that, we can just say that src dot write. And then in here, what we want to write, remember always to bring the curly bracket like this. And then the geometry, this one, we can just map it in like that. So we are mapping the line strings in like that. So mapping, and then we can map in the line. And then we added properties. So maybe I should take the properties away. Or let me just add it. It's nothing. So properties. And then the ID, let me give it a value of 1. So this one will also create a line shapefile in that same directory. If I open it up, you see that you have more files here, some of them corresponding to line. I bring up QGIS, remove this point from here. Our line is there. I can drag it in, and now I have a line shapefile. Maybe it's so small. So I can go to properties, symbology, and then this simple line. Let me just increase the stroke width to 10, very large. Apply. Okay, so this is our line over here that has been created for us with Python. Okay. Okay, I'm trying to do things in a more general way, but if you want to give the schema or the IDs any specific, as I showed you in here, where's my VS Code? Come up. You can add in anything that you want here, description, whatever. So if you want to add a value, which is like 255, you can do that. If this one takes Python data types, so the floats and all those ones that you can define inside of your GIS or your shapefiles when you are creating them in QGIS. For instance, if I come to QGIS and I decide to edit this, so toggle editing, open attribute table. If I come to this field calculator or new field, I can type in the name of a new field, maybe other. This other here, I can choose whether it's a whole number, integer, a decimal, real, or even a date. So let me just choose a string. And then here I can define the length if I want to, maybe keep it at 20, and then press OK. So it is how I want it to be. That is what I've done. So let me save it. And then now I have it here. I can edit it and put something inside of this. So as I was creating the new field, that is the properties that we add in our code. So for instance, here can be the ID or the description field. And then we choose the type here where we type int or string. That is the adding of the field is the property side that I said I will show you also in QGIS. Okay, so we have gone through how to create a shapefile. Let's quickly see how we can read it with Fiona, because now we have some shapefiles in our folder there. So we read the point shapefile. So I'll come down, give a markdown and say reading a shape file. Give it a code block. And then here, I have Fiona already imported. This is not the best practice. I don't have to import it inline all the time. But for the purpose of having all the concepts relating to the subtopics in one place, that is why I'm doing that. But if you import them once at the top, that is all, and it's cool. So here we use the same open that say, let's define the path first. And we can say with open, not just the regular open, with Fiona.open. And then here we can say path. We don't have to specify the mode as R or read, because by default this is read. If you want to override it, that is when you pass it there. So we open this one as shapefile. And then we can say for feature in shapefile, we want to print feature and see. Okay, so this should read a shapefile for us. The for feature in shapefile, what that line is doing is looping, or it is iterating through each and every feature, every geometric entity in the shapefile, and printing it out. Remember, we have 4 points in there, so it will go over each of the points and it's supposed to print it out. Okay, this is not really giving us something that is really readable and friendly. I think there's a way around this thing, but I've forgotten. There's a way around it, but at least we can see that there are 4 objects in there. So if we have 3, that should be 3. So if we change this thing to line and run our code, I'm expecting that we see only 1, because it's only 1 item in there, a single line and nothing else. So I think we can print feature dot something. Maybe feature dot, let me see, name. I've forgotten this once, the properties that we can access. I'm only trying this one out. It didn't work. So let me see. Feature has no attribute name. Okay, but we can access some features on this one. I've forgotten it. Maybe in later streams when I research on it, I will come and then show you. If you also find it, that is completely fine. But at least we know that we can print out the details of a shapefile or read it like this. Okay. As always, this is being recorded by the platform. So this one, I will try to upload it immediately after the stream so that it will not go to the next day or take more hours. So yes, you'll get it. Okay, so the next on our list is, we know how to create a shapefile. We also know how to read a shapefile. So we'll be looking at some simple geometry operations using Shapely. Once again, I cannot teach you everything on the Shapely website, but what we are doing now is not the geometry creation, it's the geometry operation. I'm hoping that should that be the not the properties, not that one. Maybe measurements should that's the operation should be there. Yes, these are the ones that we are taking a look at. So I choose to call it geometry operations. So we can compute area, distance, and bounds, and all that. So you can come to this side. Usually, this documentation is a bit detailed. It's complete. It's very good. So it tells you that you pass in the when you want to calculate the area, you pass it to your geometry, and if it's a distance, you need A and B, which is point A, point B, and all that. It even has the length and minimum clearance and everything in there. But once again, it's if you find documentation confusing, that is why we are doing this bootcamp. So let's go back, and then we have two shapefiles. Let's see the operations that we can perform on them. Okay, or we can actually even perform the distance operations and co ourselves. So what I'll do is add a markdown, and then here I will say common geometry operations. And here we will be looking at, is this a markdown? Okay, so let's look at distance. Okay, so for this one, we have already imported points at the top there, so I'll not bother myself importing it from Shapely. We can say point 1 equal to a point object, and then let's pass in 1.0, no 1.0, and 2.0. So we have defined the first point. I can copy it, paste it, change this name to point 2, and let this one be let this one be 1 1 and this one be 2 2, so that we know that the distance between them is 1 unit. If I want to compute the distance between these two, I can store it in this variable called distance, which will be equal to 0.1 dot distance. We can call it on it, so 0.1 dot distance, and then we pass in. So you take 0.1 as your starting point and 0.2 as your ending point, so you can pass in 0.2 here. If we print this distance, I'm expecting it to give us 1 unit. And if I'm wondering what coordinate system these are in, these ones do not have coordinate systems because we have not yet implemented the coordinate systems for this one. Those ones are done using PyTorch, but we have not gotten there yet. Today is just vector geometries with Python. But I know you'll be asking them, how is QGIS able to represent it if it has no coordinate system? It is something that I think it's called on-the-fly projection. If you look at the bottom right here, by default, my workspace is set to use WGS84. So if the data that is coming in does not have a coordinate system, it will project it on the fly. We say on the fly. That means as it is bringing it in, the moment it is bringing it in, it will project the coordinates onto the WGS84 space or whatever coordinate system that is set here. So that's why it doesn't have a coordinate system, but it's still being plotted. Okay, so let's run this distance. And okay, it is not 1 unit. My mathematics was very wrong, because if you have this distance like this, I think it is square root of 2. I think so. So that should be this value here. So we know that this is very correct. So that is how we compute distances in there. This distance is the Euclidean distance. Let me state it here. It assumes that it is computing on an Euclidean plane. So Euclidean distance. So take note of it. So because of that, I think if you want to really compute distances, you shouldn't use a file which is in geographic coordinate system, latitude and longitude. You have to first project it into a projected coordinate system, x, y, eastings and northings, before you compute the distances. Other than that, you get it wrong. For those ones, you compute things like the geodesic distance and stuff, but I think those were, I've not really explored the geodesic distance, but I think that should be able to cater for geographic coordinate systems. But this distance computes the Euclidean distance, so take note of that. We can also find the intersection of geometries, or maybe we can look at one of few of the distance, the things here. If we say dot bounds or dot length, it should compute the length of this line string for us. Is it a line? Okay, so let me come up here. Where's our line string? Okay, this point here, we can convert it into a line string and then compute the length of that one also. And then our line here equal to, I know maybe in your mind you are saying, Tommy, this doesn't really make sense. Why are we doing all of these things? I mean, why all of this? The truth is we will get to very fancier parts of this training where you will really love it. You will really, really love it more than you are loving this one. If you are loving this one, you will love that one more. But if you don't understand basics like this, it will be difficult for you to grasp those concepts. So please bear with me, just understand these concepts that I'm passing in, and then you will find that place to be very, very, very easy. So here I can print, I can say len, I think it's ch rather, that should be equal to line dot length. And so I can print the length. Okay. And then I get it. The line is this long, so I can get it. Automatically, the line string will chop off the last ID. If you leave it there, it will use only the first two. So that is it. Let's just be a little bit stubborn and access line.area and see what it will tell us. Okay, it failed silently, and it is choosing to return 0 because the line doesn't have an area. But I think this one can be a bit improved to tell the user that you are trying to do something that is not even real. But anyway, that is it also. So we can also, let's say, perform intersections of 2 or more lines. So I have, let's say, 2 polygons here. So I'll bring them in like this. I forgot to give a markdown for this one. So this is length. And then here I can talk of something like intersection. So we can check whether one polygon intersects the other. So I have 2 polygons here. Permit me to paste it. And then here I can say intersection. And that one should be equal to polygon 1 dot intersection. Sorry, intersection. Or you saw that it's even asking us whether it intersects, but let's just pass in polygon 2 here. And then let's print intersection to see what it will show us. If I run it, it says what? Polygon is not defined. Okay, we have not imported polygon in our stuff. So from Shapely.geometry, we want to import the polygon object. And so if we were to plot these 2 polygons, you can create a shapefile for them and then plot them in QGIS. This is where they intersect. This is where the two polygons intersect. So yes, we can know that now they intersect. So in the same way, I can check whether it intersects by saying that polygon 1 intercepts polygon 2. So that should evaluate to either a true or false. And we know from the intersecting polygon that yes, indeed they intersect. So this intersection that we printed here, you can see that it is itself also a polygon. So these are some of the vector geometry operations. As we go on in the training, we will get to use more of them, especially the parts where we are building practical examples with some of these basics that we are learning. I cannot show you everything here today. So as we go along, you get to see that we are using a lot of these things to build real problems or real solutions to real problems. Okay. I think that should do it for this. So I think our objective today is achieved. We know how to read and write shapefiles. We know how to, we know that we can represent these vectors in these three basic and atomic formats. And also we can also perform certain operations like compute length and all. So this particular, now we have a polygon here. So we can actually print the area of polygon. Maybe let's print that polygon 1. So print polygon 1 dot area, and that should give us the area of polygon 1. So the area of polygon 1 is 2.0. Okay, so that should also do for it. And I think that should do for today's session because we have achieved all of our objectives. Let me see if we come up here. Now we know how to represent points, lines, and polygons. And we know also how to use Fiona and Shapely to handle shapefiles. That is creating and reading them. The reading is what we couldn't really make a lot of meaning from the outputs that we had. I will research into that, and then the next time we'll get more meaningful output. What we see here is a memory address. We call it a memory address. This hexadecimal number is an address in your computer's memory, somewhere on the RAM. You and I may not understand this, but the computer understands this. It's like a memory address. It's like the address to your house. So if you give me the address to your house, I can follow and come to you. If you and I know how to navigate the computer's address like we navigate our streets, we can go into this address and find these objects there. So that is where the point is stored, somewhere in my computer's memory. So we have achieved that objective also, and we now know how to use Fiona and Shapely to create and to read shapefiles. I'll give 1 minute if there are questions that I'll have to address. Other than that, we'll bring today's stream to an end and anticipate for the next day. Okay, so I believe that should be all for today. I know I said it will be about an hour long, but it should be between an hour and 30 minutes. We can give it that space there, because especially the days where we'll be building some very practical scenarios, like maybe cloud masking, or the days that will be performing supervised classification. Those days might even take longer than 1 hour 30 minutes, because I shouldn't rush through. You should understand what each line of code is doing. So just psych your mind that it can be less than 1 hour, it can be about 1 hour, or maybe even 2, depending on what we are doing for the day. Okay, looks like there are no questions here, and the recording will be uploaded immediately afterwards. So don't worry about that. And if you find it difficult, maybe you have to rewatch the video, take your own notes, try out Make sure you understand it in your own way. That is the most important thing. Make sure you understand it in your own way. So if you have to rewatch the video, try and then rewatch it. And if you have questions, you know exactly where to ask them, and then you get your answer. So until then, have a great day. Those of you who are going to sleep, have a good night. And I'll see you all same time tomorrow for day 2. Until then, stay safe and it's goodbye.